Hi, I am Dr. Baby Shalini, Associate Professor, Department of ECE, Rohini College of Engineering and Technology. In this lecture video, I am going to tell you about DC to DC buck boost converters. So, a buck boost converter is a combination of a buck converter and a boost converter. So, already we have studied about buck converter, which is used as a step down converter, and a boost converter is a step up converter, and this buck boost is a combination or a cascade combination of buck and boost converter circuits. A buck boost converter is a DC to DC converter by which we can obtain an output voltage which is greater or less than the input voltage. The polarity of the output voltage is opposite to that of the input voltage. In the last two articles, we have seen about buck and boost converters. So, as I have already explained, the buck converter is a step down chopper which gives the output voltage which is less than the input voltage, whereas a boost converter is a step up chopper that gives the output voltage which is greater than the input voltage. So, a buck boost converter circuit is formed by utilizing both the advantages of buck and boost converters. So next let's see about the construction of buck boost converters. The circuit diagram of a typical buck boost converter is shown in the figure. The circuit consists of a solid state device, something like a power MOSFET, connected in series with the supply source similar to a buck converter. An inductor will be connected in parallel with the output terminals, and a diode is connected similarly to that as seen in the boost converter. The solid state device, which is basically a semiconductor device, will act as a switching device. Either a transistor or a MOSFET can be acting as a switching device. When the switching device is turned on or off by controlling the gate terminal using pulse width modulation, the circuit will operate as the step down or step up chopper by controlling the duty cycle and thus obtaining an output which is more or less than the input supply voltage. So let's consider the case when the power MOSFET is switched off. The charged inductor will start discharging with reversed polarity, due to which the diode gets forward biased. The load now receives a voltage from the supply along with the inductor voltage, that is Vin plus VL, and the capacitor will be charged. The inductor current will fall linearly until the power MOSFET is turned on again. Therefore, we can observe that the load receives a voltage which is greater than the input voltage. Hence, it is acting as a boost converter. The associated voltage and current waveforms for the boost converter is shown below. Now let's see the applications of buck boost converter. So when the battery powered system, it is used in the battery powered systems, it is used in self-regulating power supplies, it is used in power amplifiers and consumer electronics. Thank you.